Hi, physics students. Today we're going to be talking about how can we represent motion when the rate of motion is changing. We will begin by a quick review over constant speed. And recall, constant speed means that the speed stays the same throughout the entire distance that an object moves. You can also notice the motion map of an object moving at a constant speed. And the motion map of an object moving at a constant speed, you'll notice all of the arrows are the same length, and there are equal distances between each dot or each time interval of the object's motion. However, very few objects can stay at a constant speed. Often, they may move at a constant speed for a period of time, but eventually, the motion or their speed changes. Think of an example of a bicyclist. If you have ever ridden a bike before, you know that you begin from a stop position, you speed up, you probably will move at a constant speed for a period of time, but eventually you'll slow down and come back to a stop. So overall, the motion is not constant. But what would the motion map look like of a car if it reaches a speed of 30 miles per hour after moving for 6 seconds, if it started from a stop position? How would the distance traveled between each second change? Or in other words, how would the spacing of the dots for an object not moving at a constant speed look like? And in this case, our car. As the car speeds up, it covers more distance for each second it travels. So, the space between the dots becomes greater and greater as it continues to speed up. What if we were to compare two cars speeding up, both starting from the same place? In this example, we're going to compare a Kia leaving a stop sign with a Porsche leaving from the exact same spot. You can notice from the two motion maps of the car's motion, the Kia needed 8 seconds to reach its final speed, whereas it took the Porsche only 4 seconds to reach the same final speed. In other words, the Porsche was speeding up or accelerating much more quickly than the Kia. If the Porsche were to keep speeding up at the same rate and move for the 8 seconds it took the Kia to match its speed, the motion map would go off of the screen. Which brings us to the idea of a rate. A rate describes how something changes with time. You can recall velocity is the rate at which an object moves through a distance. In this case, acceleration is the rate at which an object's velocity changes. And we can measure acceleration in units called meters per second per second. Or in other words, how many meters per second a car is going more quickly per second. We can use an example of trick-or-treating to better understand what a constant rate is versus a changing rate. In this example, we're going to imagine trick-or-treaters going from house to house in a neighborhood. The rate at which they receive candy from each house is constant. In this example, trick-or-treaters receive 2 pieces of candy per home. After 4 houses, you would have 8 pieces of candy. At this same constant rate, after 6 houses, you would have 12, and so on and so forth. But what if the rate of receiving candy was not constant? Now our trick-or-treaters change neighborhoods. And in this example, they have a changing rate. Trick-or-treaters, the amount of candy that they receive per house is going to increase by 2 pieces per house, or in other words, the number of pieces of candy that they will receive will increase by 2 pieces per house for every house they visit. So after the first house, they receive 2 pieces of candy. They will receive 4 pieces of candy at the second house. They will receive 6 pieces at the third and 8 at the fourth. After 4 houses, you have 20 pieces of candy. At the same rate, after 6 houses, you would have 42 pieces of candy. And we reach a much larger number when we have an increasing rate compared to a constant rate. Let's apply this idea of an increasing rate to motion. In this example, a car begins to speed up from a stop position and reaches a top speed of 20 meters per second after 4 seconds. How much faster or how quickly is the car accelerating after each second? And you can notice from the data table, the car is going 5 meters per second faster every second. We can say the car accelerates at 5 meters per second per second. Here's another example. A cheetah begins chasing his prey. The data from the cheetah's motion is provided below. What is the cheetah's rate of acceleration? The cheetah is going 3 meters per second faster every second. We can say the cheetah accelerates at 3 meters per second per second. What would the cheetah's velocity be at 5 seconds if he continues to accelerate at a rate of 3 meters per second per second? After 5 seconds, the cheetah would be going 21 meters per second after 5 seconds.